Yo, what is up YouTube? In this video, we're going to take a look at this problem that asks us to solve the initial value problem with a second order constant coefficient homogeneous differential equation. When we see second order and it's homogeneous, the first thing we're thinking is let's go ahead and apply the characteristic equation. So in our case, we have 2r squared minus 5r plus 3 is equal to 0. So let's go ahead and find the roots using the quadratic formula. We get opposite of b, which is opposite of negative 5, which is 5, plus or minus the square root of b squared, 25, minus 4 times a times c. 4 times 3 times 2 is 24, all over 2 times a, which is 4. And this gives us 5 over 4 plus or minus 1 over 4, which is equal to 6 over 4 and 4 over 4. So r equals 3/2 and r equals 1. Given this, we can write with our general formula that this differential equation has a solution in the form y equals c1 e to the 3/2 t plus c2 e to the t. Now we're going to make use of our initial conditions to solve for c1 and c2. So let's go ahead and take the derivative of this, or let's first plug in the condition where y of 0 up here. Y of 0 up here is equal to 1. So 1 equals c1 e to the 0 plus c2 e to the 0 equals c1 plus c2. So we have c1 plus c2 equals 1. Now let's go ahead and take the derivative, and we get 3/2 c1 e to the 3/2 t plus c2 e to the t. And this is y prime. Let's plug in the other initial condition that y prime at 0 is equal to 0. We get that 0 equals 3/2 c1 e to the 0 plus c2 e to the 0. 3/2 c1 plus c2 equals 0. So now what we have is a systems of equation with these two equations, and we'll solve c1 and c2. So let's line them up. We get 3/2 c1 plus c2 equals 0, and then c1 plus c2 equals 1. We'll go ahead and subtract those. We get 0 minus 1 is negative 1. c2 minus c2 is 0. 3/2 c1 minus 2/2 c1 is 1/2 c1. So we get that c1 equals negative 2, and given that, we plug it back in where c1 plus c2 equals 1. We get negative 2 plus c2 equals 1. c2 equals 3. So we solve for those, and let's go ahead and plug it back into our original equation. So in total, we have y equals c1, which we solve to be negative 2, e to the 3/2 t plus 3 c2 times e to the 3t. And that's our final answer.